for our last workshop of the day. I'm going to hand off to Richard to talk about options, Halo2, Circom, Noir. What should you use? So.
Cool. Yeah, thanks, Paul, for the intro. And yeah, thanks, guys, for coming to the last workshop of the day. I was joking before this that the amount of people in this room is representative of the number of app devs currently in the ZK space. So kind of makes sense. So yeah. But yeah, title of my talk is Halo2, Noir, or Circom, and we're going to be exploring it from more of an app developer's kind of perspective. Yeah, so just a little bit about me. I'm Richard. I'm part of a project called Sept Labs, where we previously built a DeFi asset management protocol and launched some popular, I guess, DeFi financial products as well. There, I mostly did smart contracts and also did a lot of product managing as well. And right now, I'm learning ZK and writing a lot of ZK circuits. And I'm primarily interested in using ZK to bring off-chain data on-chain to build more meaningful applications. Some of the open source projects I'm working on, and definitely reach out or ping me if you want to collab or have any ideas. One is ZK P2P. It's a trustless P2P on-ramp using ZK proofs of email DKIM signatures, and we're doing it with some grant support from the Ethereum Foundation. Also working on an implementation of RSA in Noir, and you can see that here as well. And lastly, Halo2 doing some proving of a ZK certificate chain, I guess ZK certificate authority chaining. Cool, yeah, just quickly, this workshop is just gonna comprise of these following topics. I'm gonna give a brief overview of ZK, and yeah, disclaimer, these are kind of personal opinions and personal experience working with these DSLs. I'm a third party, not affiliated with any of the teams developing these tools above. So we're gonna start with Circom first, do a little exercise implementation in Circom. Then we're gonna move to Halo2, do the similar implementation in Halo2, and then finally Noir. And then lastly, I just have some summary points, and yeah, if there's time, we can have some discussions. Yeah, so before getting into the meat of the DSL, so why even build ZK apps in the first place? Yeah, if you can see off-chain apps, or yeah, why even build ZK apps in the first place? If you look at all these dimensions, off-chain apps right now have great UX. They're very scalable, very customizable, private between users at least, but they're terrible at being composable. And if you lose your data, you lose your access to the platform, you lose your data, right? Whereas if you look at on-chain apps today, UX sucks. You gotta use EOAs, manage your private keys. They're not scalable. They're not customizable. The whole blockchain is transparent, but they do have a great property of composability, and you do own your own data, right? And lastly, if you look at ZK apps, ZK apps basically combine the best of off-chain apps with the best of on-chain apps. So with UX, you can see more and more, I guess, account abstraction solutions being developed using ZK. There's a lot of coprocessors, rollups, building stuff that offloads compute off-chain. There's customization that can be built as well, which can build more robust on-chain loyalty programs, as well as transaction privacy, enabling hidden information games, while at the same time maintaining the composability and data ownership that on-chain apps offer. Yeah, this is a TLDR, pretty much. Web 2 is left curve. Yeah, so now that I've, man, where is this? Oh yeah, now that I've showed you on ZK apps, you realize there's a massive problem because it's really easy to get overwhelmed entering the ZK space today. There's new DSLs, frameworks, proving stacks, and research almost released like every week or daily even. There's like unique engineering quirks and gotchas because all these DSLs or languages are closely tied to an underlying proving stack. So yeah, you as an app dev basically need to make a bet on the ecosystem you want to build on, right? And it's honestly pretty similar to like back in the day, you're like betting on the EVM and building on Ethereum, right? Okay, yeah, I think we can go pretty fast through these slides because I'm sure everyone knows like ZK basics and DSL basics. So yeah, we're working with finite field elements rather than bits. In Halo2, Circom, and Noir, we're working with 254-bit integers, whereas in Solidity, we work with 256-bit integers, which is different. I guess this is also a caveat with their most common backends. Yeah, one concept I do want to bring up is the concept of having like a cryptography brain versus a dev brain when you're building circuits. If you're a regular software dev, you basically have some inputs, you apply some algorithm, and then you return the outputs. Whereas when you're building cryptographic, I guess, ZK circuits, you do have access to the entire computation trace, including the outputs, right off the bat. And that requires a little bit like different kind of thinking, because when you think about like when you want to square root something, it's just equivalent to like taking the output, multiplying by itself equals the input, right? You basically have to also flatten all computation. There's no branching allowed. This is all true for all the languages and proving stacks. So there's no ifs, no breaks and loops when you're dealing, I guess, under the hood, right? And lastly, yeah, you do have to apply a lot of adversarial thinking. So the prover is not honest. It's honestly pretty similar to smart contract engineering as well. Yeah, I can quickly just go over this. Basically, the diagram just shows the modern ZK proving stack. And as an app developer, you mainly just need to know like what's going on in the front end. And the DSL, the DSL is crucial to ZK as it translates the business logic that you have to the initial computation trace to be fed to the rest of the stack. Okay, yeah, that was a speed run through, I guess, the intro. Just moving on to, I guess, Circom. Yeah, Circom at a high level is the main language used in production apps today. Like examples include like Tornado Cache, which is probably the killer app of ZK right now in production, and also Dark Forest. And yeah, Circom offers pretty fast browser proving time because they spent a bunch of time optimizing the WASM proofs in the browser. And it also has a really fast server-side proving by using the Rapid Start framework. And Circom's relatively easy to pick up as a dev and prototype new circuits. There's this tool called, whoa, that's not, okay, yeah, that's the slide I'm on. Yeah, Circom's relatively easy to pick up and prototype using zkrepl.dev, which is a great tool. Yeah, in terms of the mental model of writing Circom, for me at least, writing Circom is basically like constructing a tree. You have like your initial signals, say it's like A, B, and C. You can add B and C together, multiply by A, it forms D, and D multiplied by E forms out, which is the final output, I guess. Yeah, Circom uses the R1CS, or arithmetization scheme, which basically expresses these gates you see in the top diagram as linear combinations. So yeah, linear combinations basically only allow plus and multiply like operators, and yeah, only quadratic constraints are allowed. But if you can see, like B and C are bundled together in addition. This is because of the R1CS property where addition gates are like free when you use this scheme in Circom. And we'll see that like addition isn't free in other, I guess, proving languages like Halo2 or Noir later. Yeah, just a quick, like, I guess, slide on the syntax. Circom basically looks like a flattened kind of assembly language plus like JavaScript. So it's very, I guess, approachable for new devs. This like fancy like arrow you can see is basically assigning constraints for this circuit on the right. There's this concept of like a single arrow you can see. It's basically you're assigning the witness, but you're not assigning the constraints, which means anything right of the single arrow, the prover can actually replace when it's actually inserting inputs into the circuit. So yeah, we're gonna also see like an example where we have to basically assign witnesses and constrain it later in this exercise. Yeah, there's no if statements in Circom, so it's very annoying to work with, I guess, as a developer. You can see like in the multi-mux example right here, I don't know if you guys can see, it's pretty small. But yeah, you're basically, CI1, and you have to subtract CI0 from CI1 and multiply it by like a selector, which is a Boolean of 1 or 0, and then you have to add back CI0. So if the selector is turned off, then you return CI0, but if the selector is turned on, you return CI1. So some like weird like math you gotta do when building in Circom. And lastly, what really annoys me about Circom is that you can't index into an array. So for example, like you have a signal B, which is calculated in circuit. You can't just index into the array that way. You have to do some like weird thing that I'm not gonna go over today. Okay, cool. That was a speed run through Circom. So I guess, yeah, we can kind of like live code, I guess, a circuit together. So yeah, the exercise I have here, you guys can scan the QR code. I'm also going to pull up my editor as well. So I'll give it a minute. Yeah, basically, the exercise is implementing integer division in Circom. So I think the meme on the right kind of summarizes our task pretty perfectly. So when you're dealing with Python, you obviously have like floating points at the end. When you're dealing with Solidity, it truncates all the decimals. But when you're dealing with ZK, you can't just do like 10 divided by 3 because it's just going to return like the multiplicative inverse of the finite field. So let me switch over then. Okay, yeah, this is the GitHub. Some instructions here, but we'll start with Circom. And with Circom, I think we're just going to use the ZK REPL tool because it's much faster to prototype than installing, I guess, Circom and Snock.js locally. Oh yeah, the other I guess assumption here is we have to assume where x and y, where we feed in as inputs, are non-negative integers that are less than 2 to 32 bits, and we'll see that is important in a minute. Okay, cool. So yeah, I've already pre-copied over the template that we're gonna like build together. I guess like since it's a pretty small group of people, feel free to like jump in if you have any ideas, like how to start and what you guys want to do. Okay, I guess I can just start.
Can you
like,
maybe zoom in a little bit?
Yeah, that's a good idea.
Perfect.
Okay, you can kind of see in this template that it's basically taking in two inputs, x and y. You basically want to calculate the quotient, which is the integer of when x divided by y. And you want to do that within the circuit, right? So I think like the first thing that you might want to do, you might try to do is you want to do this, right? Like ideally that is what, like as a software dev, you would want to do when you want to divide integers, right? But yeah, as you run the code, you can kind of see, yeah, non-quadratic constraints are not allowed. And that is, I guess, the #1 error that Circom devs run into. And it's the most annoying, I guess, error as well. I think that's because of the reason that when Circom compiles x divided by y, it thinks it's trying to calculate the multiplicative inverse of it. So you can't do that. Luckily, Circom has like an operator, which is this, the forward slash, which basically means like do integer like division. But like if you run the code again, it's still showing this error. This is because the circuit doesn't know like what integer division is, right, at the lowest level. So you need to come up with an alternative way to do that. And yeah, I guess this is where it's important. This is where like you kind of need to use like this single arrow. And as I kind of mentioned earlier, single arrow means like you basically do some computation outside the circuit and then feed it in as input here. So in this case, x and y, x like I guess forward slash divided by y is not constrained, I guess, in the circuit. So when you actually prove it, like the prover can just insert whatever values they want in to the right of this arrow, right? But for our purposes, we need to first calculate the quotient and then constrain it later. So that is important. I guess, yeah, so given that, I think if you run it, it's not going to fail. So that's already good. The second thing you need to do is you need to kind of calculate the remainder. Because all integer divisions kind of return a remainder. So you would do modulus y in this case. And you would also use single arrow because it gives the same like error previously of non-quadratic constraints, because modulus isn't recognized as a valid operation in a circuit, right? And then, yeah, so you kind of have these two values that you have, or you kind of have this quotient and remainder value, but you haven't done any constraints on it quite yet. So you got to find a way to constrain it. And I guess the way to do it is you want to kind of reconstruct. Oh wait, I need to declare intermediate signal. All right. Yeah, the way to kind of do it is you want to reconstruct x by taking the quotient multiplied by y, and then add back the remainder. And then you want to constrain that to be x, right? Okay, that also, you also run into that with ZK REPL dev. Okay, cool. Okay, run it again, it passes, and you can see the output is 2. So we've done integer division correctly, but there's another, I guess, issue with this. I guess, do any of you guys have any ideas?
relative numbers?
Yeah, exactly. So we're operating, I guess first off, we're operating in a finite field. So you can think of the prover being able to insert any quotient or any remainder, I guess, inside the circuit, because we've only used single arrows here, right? So there's no constraints to quotient or remainder. So basically, prover has two variables to play with. And since we're in a finite field, there's like an infinite number of or a large amount of quotients that are valid and a large amount of remainders that are valid that they can insert into this. I think I have an example here. I need a copy. I can do that really quick. Okay, first I need to do this. This is all live coding, so bear with me. So this is some random large field element. That is the inverse of y. And I think if we plug in, or I guess of x. If we plug in x, it would pass. Oh no, that's not right. Remainder 0 quotient. Oh yeah, quotient 1 is 1. Yeah, I think it basically just, all right, yeah, I think, where was I stuck? Yeah, I think basically if you multiply it this way, then you can kind of insert infinite amount of, or any kind of quotient where it satisfies this, and then where the remainder is 0. You can plug this in and it'll reconstruct, and it'll make this test, or make this input pass. Still. And so, yeah, I guess the solution to remedy this is you do need to add range checks at the end to ensure that the number is non-negative and it's not greater than 32 bits as part of the inputs. So for that, we need to introduce components, and so Circom has this less than chip or less than template where you can use to pretty much check the range. Yeah, you basically have to check the quotient is less than x, or less than or equal to x, and that the remainder is also less than or equal to x. And then that should, yeah, it doesn't show up in the, I guess, in the outputs, but that basically means that you've sufficiently constrained it properly. And I guess if you look into the less than or template itself, it ensures that the values cannot be negative as well. So yeah, that's kind of the solution for Circom. And it's a very roundabout way to implementing integer division. And it kind of sucks if you're like a software engineer trying to learn ZK. Cool. Yeah, and I guess like the solutions are in GitHub if you switch the branch to solutions as well. So yeah, you guys can take a look at it on your own time. Cool. All right, so that's Circom.
Can I ask questions?
Yeah, go ahead.
How much gas would it roughly cost to validate it on chain?
Yeah, it's around, so Circom with a Groth16 backend takes around like 300K, like base. And it depends on the number of public inputs you have. The more you have, the more like it increases from there.
That's a cold data, right?
Yeah, the call data. Yeah, 300K.
Roughly 300, and we're talking about growth 16 then.
Yeah, Groth16 in particular.
I saw there is a Plonk also option too.
Yeah, there's Plonk, and then there's also like Nova Scotia, which is Nova in the backend coming out soon. But yeah, they're different.
Do
And
you know how they differ in the gas cost?
I think I don't have the specific numbers for Circom plus Plonk, but it's more than Groth16.
Other than that, other than cold data, it's pretty constant cost, right?
Yeah. 300K is the constant. Yep.
Also growth 16 as well, right?
Yeah, Groth16. Yeah.
Awesome, thank you.
Yep. Cool. I'll move on to Halo2 now. So Halo2's originally developed by Zcash, and the current version right now is maintained by PSE in the Ethereum Foundation. And there's a couple projects building libraries and tooling on top of Halo2. And these include ZK Email, Axiom, Scroll, and EZKL. Strictly speaking, Halo2 is a library in Rust, not a DSL in the strictest sense. But yeah, for our purposes, we'll treat it like one in this workshop. And today, we're also going to be focusing on what Axiom developed, their Halo2 lib, which is considered as an eDSL, or an embedded DSL, which basically means it's a library built on top of vanilla Halo2 that abstracts away a lot of complexity with dealing with Halo2. And I guess, in my opinion, much easier to get started with, and actually makes Halo2 a lot more approachable. Yeah, so Halo2 is good because it has a very fast prover, good recursion, and yeah, very customizable like front end that you can plug into multiple backends. So compared to Circom, the mental model for me for writing Halo2 is like assigning cells in a gigantic spreadsheet and specifying the relations between those cells. Or another alternative way to think about it is kind of like building a Sudoku puzzle. Like there's only one way to get the right answer, given like all these predefined, I guess, numbers, right? So in vanilla Halo2, you can that enables you to create custom gates with many columns in the spreadsheet. But today we're going to focus on Halo2 lib, which is by Axiom. So it only and their specific custom gate that they offer is a single vertical gate with a single selector. And if you look at the table on the right, you can see there's only one advice column, or a single column. And then the selector is like, I guess, a fixed preprocessed column, which doesn't affect the witness generation. So you can see like on the table on the right, you first load in X, which is just a value, and you copy X into row 1 and also row 4. And then you also assign a constant 1 into the spreadsheet. And then for the very last row, you're basically specifying that I want to add row 2 plus the multiplication of row 3 and row 4. And that kind of is specified by this selector right here in bold. And as you can kind of see, that addition and subtraction aren't free, because you do need to assign cells for, I guess, yeah, for any kind of operation that requires these. And that's different from Circom and R1CS, where if you have a lot of addition, it's basically free for you.
In Circom, addition and subtraction is free.
Yeah, yeah, yeah.
It's independent from Gross 6 or UltraPlonk, right?
Only Gross 16.
Only Gross 16.
Yeah, yeah. Yeah, just a little bit about the Halo2 lib syntax. Basically, there's these two templates or two libraries, gate and chip, or gate and range, which implement helper functions. And these helper functions are basically templates that you saw in Circom. And these basically interact with the custom gates under the hood, so you don't have to. And it actually makes developing much easier. So if you can, I don't know if you can see on the right, on the left, in the select helper function, you're basically assigning 8 rows in the table. Yeah, you're basically assigning 8 rows in the table, right, to do a select. And select in this case means like an if statement inside the circuit. And yeah, the downside, I guess, I would say, of building Halo 2 circuits is it's easier to mix up writing in circuit versus out of circuit logic, because all Rust is valid and Halo 2 is a Rust library, right? So you got to remember to use select, which has that API, versus using like if in Rust. Whereas in Circom, if you try to use an if statement, it'll just error on compile for you. So you got to be a lot more careful, I guess, writing Halo 2 circuits. Yeah, so because Halo 2 is kind of like you're assigning cells on a spreadsheet, you can kind of plot out what it looks like. And this is just the simple, I guess, plot of what the previous circuit looks like. All the column on the left is all the witness values that you assign. And you can kind of see that number of cells will always be the same in Halo 2, but the rows and columns can be configurable. And so what that means is you can make it like, I guess, 2 columns, for example, and reduce the number of rows you want to use. And the trade-off is that more rows means higher cost to prover, and more columns means higher cost to the verifier, for the most part. There's some additional, I guess, nuance to that. And rows, additionally, must be like a power of 2. In this case, in this diagram, I guess you can't really see, but k equals 4 in this case. So there's 16 rows in this table. And the red is like the last 7 rows, and it's like blinding factors. And basically, you need that to preserve zero knowledge, I guess, in Halo 2. OK, yeah, that's a little overview of Halo 2 lib. And I guess we can move on to our second exercise, which is implementing integer division, but this time inside Halo 2. And I think I need to switch to my screen.
Would you be able to increase font a little bit?
Yeah. Okay. So if you guys have your laptops and are following, I'm in the lib.rs file within the Halo 2 int div. And yeah, you just have to cd into the Halo 2 int div folder to run any, I guess, cargo commands. As you can see, I guess already with this scaffold, there's already a bunch of code that you need to like set up even before building any kind of in-circuit logic. Yeah, so I'm basically just specifying a new chip, instantiating, I guess, some of the axioms, axioms helper functions, and yeah, just created a function here for integer division. And yeah, basically you guys kind of already saw how to implement it in Circom, that you need to assign witnesses first and then constrain it later. So I'm just going to type that using Halo2 syntax. So you basically need to, specify a quotient, and it's just x divided by y. Yeah, and the benefit of, I guess, using Rust is you can just use Rust. Benefit of using, I guess, Halo2 is that you can just use Rust to do division and modulus. Yeah, so you implemented, so you first do the calculation of quotient and remainder, but then you need to load, I guess, the quotient and remainder into the table. And that requires calling, let me see what API did I use. Oh yeah, self-range. Sorry, loading is different. You need to load the witness into the table. So quotient and remainder are tracked. Okay, yeah, now that you've quotient and remainder in the table, you kind of need to reconstruct x and constrain it that way. And so constructed x equals, and when you reconstruct x, since you're doing it within the circuit and not outside the circuit, you have to use Halo2 libs helper functions. And so it goes self.range.gate.mul, or I'll do it the easy way. Mul. Do quotient times. Okay, this is really hard. You also need to load y into the table because you're using it within the circuit. Right. Constructed x. Okay, yeah. ChatGPT or Copilot. Okay, yeah. Once you multiplied quotient by y, you need to add in the remainder. So yeah, it's basically these two lines of code. And there's a mul and there's an add. And yeah, you just need to return restricted x. Yeah, and I guess to test what you built, you can just run it and oh yeah. Oh, there's no return. What the? Value. Oh yeah. Yeah, field. So field just wraps the value into the Halo2, I guess, prime field. Oh, whoops. Return quo. Okay, yeah, test pass, but as with the Circom example, you do need to range check. And range check is, or sorry, you need to first constrain equal reconstructed x and x. Then you need a range check. Yeah, you basically need to make sure quotient is less than 32 bits, and also rem is also less than 32 bits. And that ensures that you don't, prover can't be dishonest.
And does that already check if it's a negative?
Yeah.
Because it's unsigned, or?
Yeah.
Zero to the, it says lie in the range 0 to.
It only populates 0 to 2 to the power 32.
Yeah, where's the docs? Yeah, it's somewhere in the docs.
Yeah, it's if you go just below, yes, on this line 534.
Okay, perfect. Yeah, great. Yeah, if you look in the API, they have. Yeah, cool. Cool, yeah. And make sure that it's non-zero in the range check. Or non-negative, sorry. Yeah, really. You also have to load X into the witness table, so I'm doing that here. Yes, as you can see, there's a lot of overhead in converting types in Halo2. Cool. Yeah, that should. Oh man, no. That's close. Oh, wait. I need to actually.
Is it just reference?
What's that? I think I just need to load X into the table. That'll solve everything. Okay, cool. All right, that should be it, and it should pass if no. Okay, cool. So yeah, this is basically. This is basically what you needed to implement integer division in Halo2. I guess it's not great, but it's still, I guess, it's getting better, I guess. I would say that. Cool. I guess like we're 45 minutes in. Just enough time to go over Aztec, Noir.
And what would be the gas cost if you compile it to solid
In for Halo2,
yeah.
it would be around, I guess, 400K all in. I think you could optimize it to like 2 280 at the minimum, but like I think for normal purposes, it's probably 4. It depends on like aggregation, recursion, and how many columns in the table you have.
So it's very non-linear in this case.
What's that?
It's non-linear in this case.
Ye- Yeah, I think it's, yeah, I'm not sure. I need to double check on that. Yeah. Cool, yeah. Just quickly, Noir. I mean, if you guys attended the Noir workshop before this, you kind of already have a sense of what Noir is. It's, yeah, this new language by Aztec compiles to any number of backends, right? And kind of removes that need of the cryptography brain when writing circuits. It does have if statements, casting, and bit shifts in the syntax level, so it makes it easier, I guess, to program your apps. It has a lot of nice tooling, but the drawback is that depends on the size of the circuit. Noir is like could be up to a couple times slower than Circom and Halo2 when proving. Oops.
You're talking about the size of the circuits produced or the...
Proving time. Depending on the size of the circuits, yeah, produced. The proving time may be a couple times slower for a similar circuit.
So if you use Halo2 with Noir and just Halo2 by hand, the circuits are bigger with Noir? Is what you're saying?
I guess I'm saying like dependent on your business logic. Like, given the same business logic for Halo2, Circom and Noir, Halo2 right now, or I mean Noir right now, may be like less efficient, depending on the circuit you're trying to write. Yeah, in terms of arithmetization, it's kind of different from Halo2 and Circom in that it doesn't actually compile down to the constraint system. It first enters this like intermediate thing where anyone can take the trace and apply any arithmetization to it to connect to a backend. So by default, Noir uses like Aztec's like UltraPlonk backend. Yeah, I'm not going to go into this too deeply, but basically it abstracts away a lot of the complexity of writing, I guess, circuits from a circuit developer perspective. And like casting in this case, you see, is basically that range check code we wrote with less than in Circom and range check in Halo2 lib. You can just do something like as U32 or as U64 to do that range check for you. But the downside, I guess, is all computation is constrained by default, which is safe. But if you want to do what we did, where you do the single arrow in Circom or native Rust in Halo2, you have to prefix the function with unconstrained. And yeah, we can kind of go to our last exercise for the day. Just implement the same thing, integer division in Noir, and I guess I'll switch to the editor again. Okay, so I am seeding into the Noir intdiv folder, and I think there I've already installed Nargle, and I've set up the, I guess, template for integer division, and yeah, we just need to implement it. And yeah, I think in Noir it's actually pretty straightforward. So the inputs are to the function I have here is field. We kind of need to range check that, ensure it's a U32, and then basically divide that. And so in Noir, it's kind of like this. first have to cast X as a use32, basically means it's range checking. Y as use32, it range checks. And I think I have the function signature return a field, so you have to convert it back to a field. And I think that should be it. And yeah, just checking with Nago test. Yep, that's it. I guess that's all the lines of code you need to do integer division in Noir. And it's, as you can see, it's much less overhead in implementing, I guess, this. And you don't really need to think about any of that assigning witnesses or, I guess, yeah, assigning witnesses or manually calling range checks. But yeah, this is a simple example. It highlights, I guess, the benefits of Noir in implementing simple apps. But obviously, as I mentioned, there's some like trade-offs to be made as of right now because it is very experimental for larger circuits. Yeah, I guess I have a couple more minutes. I do have some more slides just summarizing kind of what we talked about today. I can go over them relatively quickly. Yeah, in terms of like DevX, as I just mentioned, Noir is great. Wins by far for building ZK circuits as like a beginning circuit developer. There's great docs. There's a great package manager, and you can write stuff like normal software. And Circom, it's relatively easy to prototype still with ZK REPL, but syntax limitations force you to think like a cryptographer, and it's annoying. Halo2 is most flexible, but you do need to have experience with, I guess, switching between native Rust and in-circuit logic. And there is that overhead of scaffolding and imports that you need to be careful of. In terms of availability of primitives, Circom, by far, I think, has the most libraries ready to use by devs, and also, libraries, the amount of libraries used in production. Halo2, there's an emergent ecosystem with Halo2 lib. There's less libraries in production, but I think it's rapidly increasing as well. But obviously, it's way less usable. And in terms of Noir, it's still very early. The library is not production ready and very experimental, but I think the pace of development is really fast. And yeah, the team is great at helping debug issues for you. In terms of privacy, if you're looking at it from an app, if you want to incorporate that into your app, Halo2 is very fast. You can, if privacy is essential, you're able to generate a proof locally in browser and then recurse that into a server that's like GPU accelerator or whatever without loss of privacy. But obviously, larger proof size and there's way less WASM tooling. In terms of Circom, it's slow if you want to do privacy, but it's hyper optimized in terms of WASM. You can prove up to $20 million or 20 million constraints. In terms of Noir, it's also similar to Circom right now. And in WASM, you can prove up to 512K constraints, which is way less than Circom at the moment.
The goal of WASM proving is for it to run in the browser.
Yeah, in browser, so you can preserve the privacy. Because if you're running in a server, you're basically sending the server all your private inputs, right? Yeah, I guess talking about overall proving, regardless of server or in browser, Halo2 is the fastest. You can kind of customize your columns and use servers with high memory. Circom's also pretty fast with rapid snark. It's 10 times faster than in browser. And Noir, yeah, as I mentioned previously, it's it's experimental. A lot is being built right now, but yeah, it heavily depends on the circuit you're trying to prove.
Sorry. So in the case of Halo and Circom, you need to do these computations in the language. You witness this stuff, and then you be able to grab constraints.
Mm-hmm.
So when you're trying to, so in my head there are two steps. Right? You want to generate the circuit,
Mm-hmm.
then once that's done, I want to generate my witnesses, and I'm going to do this a bunch of times.
Mhm.
I'm going to review this
Yeah.
circuit.
Yep.
So every time I'm going to generate a witness, I am also rebuilding the circuit, right? With that approach.
You're revealing the circuit?
No, rebuilding. So
Oh.
every time I'm going to rebuild
Or you're not recompiling, or you're not redeploying the circuit, as in like you're not regenerating proving keys. You're keeping the same proving key, but you're feeding different inputs into it. But you are generating the proof. Is that what you were asking?
So in the body of the functions we were defining for this multiplication,
Yeah.
we were doing some computation, for example, in Halo,
Mhm.
and Rust. So if you
Yeah.
Rust, that's what you're witnessing. And then you take your context and you start adding constraints in there.
Mhm. Yeah.
So adding the constraints part is useful only if I want to generate a circuit.
Yeah.
If I've already done that, then I only need the witnessing part.
Yeah. Yeah.
But that function is going to be run anyway. So every time I want to generate a new witness, I will populate this context and will carry it around.
Yeah, exactly. You would have to repopulate the table. The context is just the table in the back end.
I don't think it's super expensive facility.
Yeah, exactly.
It would be nice to split the two processes into different things.
Yeah. I think it's two different processes right now. There's like the witness generation and then actually generating a proof. That is, I guess, that is broken down right now in in Circom and Halo 2 right now. But yeah, I think that's a good point. Yeah, I guess this is the solidity verification cost that you were asking. Circom's by far the cheapest. Halo 2 Noir use Plonkish and are around the same. Yeah, this is almost the last slide. Basically, overall, I would recommend that if you're a new circuit developer, you want to go from 0 to 1 the fastest. I think you just pretty much should just use Noir. The tooling's great, very easy to onboard to, but you trade off some efficiency as you're writing large circuits right now. But the ecosystem is developing very quickly, as I've seen. And Circom is kind of like that intermediate thing. If you want to go from 0.5 to like N being like production, it's a good fit. It's beginner friendly, fastest to productionize your app, but performance deteriorates if you want to preserve privacy. And Halo 2 is even harder to use than Circom, but I think there's some tooling and ecosystems being built that make it much more approachable. And yeah, lastly, there's some stuff I don't cover today, but I'm interested in. And they are Plonky 2, Risk 0, and I guess the Nova Scotia kind of backend that uses Nova, and it's built as a backend for Circom. And yeah, that's it. Yeah, thanks for coming. It's a pretty long workshop. Had to cram a lot of content. And yeah, thank you all for being app devs in ZK. Cool. Yeah. I also do have like the resources list on the right, which I used as reference to construct these slides. So I'll be posting everything there as well. Cool.
In Plonk 2, we are free to not use the ZK property, which makes the Plonk 2 faster, according to the ZK stuff. And is Halo 2 providing this kind of option to us? Or
Non-ZK.
because, for example, rollup something doesn't require any kind of ZK features, but
Oh yeah. Yeah, I think the production apps using Halo 2 today don't preserve privacy. Like Scroll, obviously, they're building on Halo 2. Axiom coprocessor doesn't require privacy. They're also building on Halo 2. So yeah, I think the production apps right now don't have privacy in Halo 2. Cool. Yeah, I think that's it. We're like at time, so thanks.